Okay, I'm back. I'll finish up our experiment. So we got to do the paper again, of course. It's in the name of science. This piece is a little bigger, so I'll be a little more safe. And yeah, that's quick. It's pretty amazing. The white piece of paper turns to black, giving off smoke. Those are our basic observations. Let me take the 1 or 2 centimeter wood flint. We've actually done this before for hydrogen tests, but again, in the name of science, we got to do it again for a different purpose, and that's to actually just look at it and watch the wood. And so that is just turns black real quick, glowing, goes out, simple, also produces smoke. Okay, let's try this stretched out piece of steel wool. Steel wool again is pure iron, so I'm gonna burn iron, and yeah, this is awesome. Kind of like a little fireworks show, tiny little fireworks show. Little balls of flame traveling up and down the strands of iron. I think I got it all. A little bit of smoke, but I'm wondering if actually this smoke is just some sort of heat, because certainly less smoke than the paper and the wood. So that's an interesting difference to think about. But again, same thing. The steel wool was kind of grayish before, now it's really a lot darker, more blackish. So, okay, those are the results. I'll be back in a second. We'll see if we can make sense of these results. So hopefully you had some fun and enjoyed burning things, and hopefully you were safe and everyone is okay. So what I would like to do right now is relay some thoughts that we have, observations that we had from running this experiment. And they really come down to 3 main things. The first one is actually kind of obvious. First, fire requires something to burn. In other words, fire, that hot glowing stuff, emerges when a burnable substance is ignited or held in a flame. But the fire extinguishes when that substance is used up, just stating the obvious. Second, the leftovers after a substance is burned are very different from the original substance. Forest fires, horrible and destructive though they can be, leave behind trees which look nothing like the trees look like before the forest fire. You can't write on paper that's been burned, but you can write on paper that's not been burned. And thirdly, fire seems to release some sort of gas or smoke that goes up into the air. So 3 just basic observations that we should be able to convey to each other. So back to Johann Becher. As I mentioned, he grew up in the world of alchemy in the late 1600s and was taught that fire was one of the 4 classical elements making up all matter, every substance known in the universe. And those 4 classical elements were fire, earth, water, and air. But by the time Becher was an adult, these ideas were changing, and scientists around Europe were less convinced of this old Greek 4-element theory and began stretching and pushing new ideas of chemicals and chemical changes and conceptions of matter. So in 1669, now a full-fledged experimentalist, basically a professional scientist, Becher was joined by his student, Stahl George Ernst, and together they questioned and tested many of these new ideas about fire. They laid the foundation of a new theory that would drive the development of chemistry for the next century. And really, this is the late 1600s, really almost more than a century, almost up to the year 1800. So rather than view fire as an element, one of the 4 elements, Becher and Ernst began to see fire as something temporary that exists only during a chemical change. In particular, the 2 theorized that there exists a special chemical called phlogiston. So they weren't saying fire wasn't a thing, a substance. They were saying it was a chemical called phlogiston that exists in all burnable substances and produces heat or fire as it is released into the air. Something like wood that leaves a lot of ash behind must have a lower content of this phlogiston, this burnable stuff. While candle, which leaves almost no ash, must be almost pure phlogiston. So the 2 chemists came to this conclusion by carefully observing the process of burning, like we did, and the changes in materials that were burned. Most importantly, they observed that burning seems to clearly impact and change the air around it. And this is what we'll be focusing in on in this course. So this seems obvious, but remember that in the 1600s, Air had always been considered to be an unchangeable element, a foundational element. Air is air is air. But now we're suggesting air can be changed. So this is kind of radical. So let's keep an eye on this air as we continue our investigations.